Welcome to Online Algebra 2. This is 1-5, Solving Inequalities. So our objective for this section is to solve and graph inequalities and to write and solve some compound inequalities. And just like you know that you use the properties of equality to solve equations, we could use those same properties of equality to solve inequalities. So let's talk a little bit about what inequalities are and what their graph looks like. So we have four basic types of inequalities: greater than or equal to, less than or equal to. And all of them are represented by the graphs on the right. And you can see with the greater than, the graph shows numbers that are greater than 4. And we have this open circle here at the boundary point of 4. With greater than or equal to, the graph shows, again, numbers that are greater than or, with the solid dot there, equal to 4. With less than, we see the graph goes the other way to the left, covering numbers that are less than 4. And with our open circle there, and our closed circle for less than or equal to. So in those graphs, the point at 4 is called the boundary point because it separates the graph of the inequality from the rest of the number line. Open dot at 4 means 4 is not a solution. Closed dot means it is a solution. So when you have that open dot, it's sort of saying that the answer is everything except for 4. What's greater than 4? 4.1 is greater than 4. So you want everything in there except for the actual number 4. Okay. So let's write an inequality from a sentence, words to math. So write an inequality representing the sentence 5 fewer than a number is at least 12. So let's start with this first thing, 5 fewer than a number. Well, if I want 5 fewer than a number, I got to subtract something. And I'm going to compare it to 12 with an inequality symbol, at least. That means 12 is the smallest that you could get. So that means x minus 5 has to be greater than or equal to 12. Okay. 4 less than a number is greater than negative 28. Well, that one's a little bit simpler. We can just write that with the greater than symbol. Twice a number is at least, same thing, at least 15. So that means 15 is the smallest number that this expression could be, which means that this part of the expression has to be greater than the 15. Number increased by 7. Well, if I wanted to increase by 7, I'm going to add 7 to it. Less than 5. Okay. And the quotient of a number and 8, so quotient means division, is at most negative 6. That means I want this part to be less than or equal to negative 6. The most the left side could be is negative 6. All right. The solutions of an inequality are the numbers that make it true. The properties that you use for solving inequalities are similar to the properties that you use for solving equations. However, there is one big thing that is different. When you multiply or divide each side of an inequality by a negative number, you have to reverse the inequality symbol. That is the most common mistake that people make when they're solving inequalities, is you have to remember that when you use a negative, when you multiply or divide by a negative number, you have to change the sense of the inequality. So if it's greater than, it turns to less than. If it was greater than or equal to, it turns to less than or equal to, and vice versa. All right, so here's my properties. Transitive property, just like the transitive property of solving equations. So if A is greater than B and B is greater than C, then A is also greater than C. So addition, if we add c to both sides, if we add c to one side, we have to add it to both. If we subtract c from both sides, we have to subtract it from both. And here's the multiplication and division. So if I multiply one side by c, I have to multiply the other side by c. But if c is negative, I change the direction of the inequality sign. And same thing for division. If c is negative, if we're dividing by a negative number, then I have to change the direction of the inequality. Okay, let's see why this actually happens. Okay, so let's do a quick little proof here. So if you want to see why this actually works, if I want to multiply everything by -1 and show that this inequality must actually change direction, we can do that. So let's start by subtracting b from both sides. So that's a minus b is greater than 0. Okay, so my goal is to get here. My goal is to get to a negative on the left and a negative on the right without messing around too much, without multiplying anything by a negative. Okay, so let's reverse this. So let's use the commutative property. So that's negative b plus a. Let's make this a negative by subtracting a negative. Okay, well, we can do that. Now, right, we can do the opposite. I can add a negative a to both sides. Now, that seems like it's a little weird, which it is, but by doing this, I now can see that negative b must be bigger than negative a, and if I flip this inequality around, I now can see, right, this is still opening towards negative b, that negative a is less than negative b. We took the inequality and we reversed it when these two terms are multiplied by -1. When they change sign, the expression reverses. Okay, so that's a weird little thing that we do. You don't have to go through this every time you're trying to solve a problem. Easier just to remember to reverse the sense of the inequality if you have a negative number. Let's try some problems. So, multiply -6x plus 15 plus 1 greater than or equal to 4. Combine like terms, greater than or equal to 4. Subtract a 16 from both sides, and now we have -6x. It's greater than or equal to -12. When I divide both sides by -6, now the inequality must change. Okay? And my arithmetic doesn't change, right? Negative divided by negative is still a positive. What changes is the direction of the inequality. To graph the solution, I just find the boundary point. It is 2. And then, because it is or equal to, I'm going to put a dot. Now I have to decide which way to make my graph go. Well, x is less than 2. X is less than or equal to 2. That means that I'm going to want all the numbers on the number line that are less than 2. And if the variable is on the left, which it is, the inequality symbol will actually point the way that you are supposed to go with your inequality. The other way to do this is pick a test point if you're not sure. I like to pick 0. So plug 0 in for x. 0 is less than 2. That is true. That means 0 should be covered up by the answer, which it is. If I pick another test point, 10 is less than 2. That's not true. So 10 should not be covered over by the line. All right? And that's an easy way just to double check and make sure your line is going in the correct, your graph is going in the correct direction. Let's try another one. Distribute, combine like terms, solve for x. So we get -2x minus 18 plus 5. Okay. and negative 2x. We have negative 18 minus 13 greater than or equal to 3. Add 13 to both sides. Negative 2x is greater than or equal to 16. And now I'm going to divide out the negative 2, remembering to change the direction of the inequality symbol, and I get negative 8. Close circle, and not too much to color this time. To the left, x is less than or equal to negative 8. If you're not sure, plug in that test point of 0. Is 0 less than or equal to negative 8? No, it is not. That means it is not covered over by the graph. Try a word problem. So a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as you want, or $15 a month and $1.50 to rent each movie. Textbook's a little old, so no Netflix yet. How many movies must you rent in a month for the first plan to cost less than the second plan? Okay, well, let's think about this. The first plan was $36, right? $36 a month. The second plan was $15 plus $1.50 times the number of movies that you rent. And the question was, how many movies must you rent for the first plan, 36, to cost less than the second plan? And there we go. So now all we have to do is solve for x, subtract 15 from both sides, and we get 21 is less than 1.5x. Divide out the 1.5. Oops. And we get that 14 is less than x. So you have to rent 14 movies. As soon as you rent the 15th movie, the other plan will cost more. Actually, you have to rent 13 movies, right? Because as soon as you rent the 14th movie, the 2 plans are equal to each other. So you just gotta figure that one. Okay. All right. So we can also have situations where we have variables on both sides, and the inequality is always, sometimes, or never true. And just like last time, the variables will cancel out, and you have to look at your expression. Okay, so it's not quite as looking at it and making sure the numbers are exactly the same like they are in an equality. You have to read the statement and see whether it's always true, sometimes true, or never true. If the variables all cancel out, it's not going to be sometimes. It's either always or never. Negative 6x minus 2 is greater than negative 6x plus 7. Add 6x to both sides, and we get negative 2 is greater than 7. Okay, so is negative 2 greater than 7? No. So this is never true. Okay. For part B, distribute, combine like terms, see where we have left. So 10x minus 15 minus 7x less than or equal to 3x plus 8. Less than or equal to 3x plus 8. The x's cancel, and we have negative 15 is less than or equal to 8, and that is always true. An expression like this with the word problem, or like this one is sometimes true. Here it's true, here it's not true. Okay, so if you get a solution, if you get the variable to be by itself, then your answer is going to be sometimes. If the variables cancel out, then it is always or never. Let's try one more. So that is 8x minus 12 is less than 8x plus 8. The 8's cancel, so negative 12 less than 8, and that is always true. Negative 12 is less than 8. All right, so we can join two inequalities with the word and or the word or to form a compound inequality. The and inequality is when you put the two solutions together, this solution and this solution, and you see where they overlap, they both have to be true. With or, we're saying this one or this one, so either one could be true. Okay, so to solve a compound inequality containing the word and, find all the values of the variable that make both inequalities true. You see where they overlap. So it's basically like solving two separate equations. So we have this one and this one. Let's figure it out. So we have 7 is less than 2x plus 1. Subtract 1 and divide out the 2. Now, don't get confused here. 3 is less than x. Okay, so on the graph there, notice that my variable's on the right-hand side. Okay, my graph is now going to go this way. Okay, so here's the graph of 3 is less than x. 3 is the smallest thing on the graph. X is bigger than 3 because 3 is the smallest one. Less than or equal to 18. Divide out the 3. And we have x is less than or equal to 6. Let's clear this for a second. Hold on. Clear this graph. Let's graph this one in red. So we have an open circle going this way. Let's graph this one in blue. So now we have a closed circle going this way. Okay? And so the answer, the place where these two overlap, is from here to here. So the green part is my actual answer. Okay? So we can get rid of the blue and the red, and you can see that just the green part is my answer. From 3, not including 3 to 6, is the place where both of these expressions are true. Okay. Okay, another problem. So we have, I didn't put a graph here, that's okay. 3x minus 1, add 1 to both sides, less than or equal to 3x. Always make sure that if we're dividing or multiplying, that's not by a negative number. It's not here, but just make sure it's not. 2x is less than 12. Divide out the 2. Okay, so if I were to have a graph here, I would want to, let's go 0, 1, 2, 3, 4, 5, 6. Okay, so 2 is less than or equal to x, so that's where the graph starts, and it goes to 6 with an open circle, and it stops there. Okay. If you're going to graph this with interval notation, we didn't really talk about that too much, but with interval notation, right, that would be a bracket to 6 parentheses. And if you've never seen that before, there's a video on it. We'll do that again later. You can also collapse compound and inequalities, like 5 is less than x plus 1 and x plus 1 is less than 13, into a single inequality. Okay, that would be 5 is less than x plus 1 is at less than 13. Okay, or x plus 1 is greater than 5 and less than 13, right? X plus 1 is in the middle of 5 and 13. You can solve this just like an equation, except if I'm going to subtract 1, I don't do it from one side, I do it from all sides. So this would be 4 is less than x is less than 12. So x is in between 4 and 12. Okay? And so the graph of that one, right, for 12 would just look like that. That x is somewhere in between there, not equal to either one. Okay? To solve a compound inequality containing or, find all the values of the variable that make at least one of the compound of the inequalities true. So that means that you're going to have one or the other. So for these two, where you see the word or in there, we subtract off the 7, and we have that k is greater than or equal to -1. Subtract off the 8, and k is less than -5. And greater than or equal to -1 goes this way. Less than -5 goes that way. And that's my solution. All of that stuff. Okay? Everything except for this little piece in the middle there is part of the solution. This side or this side. One or the other. Only one of them has to be true, not both of them. Okay? So let's do both of these. Both of them are an or inequality. Subtract 3 from both sides. 7w is greater than okay. That is not quite a nice solution, but we can deal with it. Divide out the 7, so w is greater than 8/7. Unless I missed something here. No, okay, not much there. Add 1. This one's a little bit nicer. That might have been a typo in the book to make it that hard, but it's not terrible. So w is less than -3. So on my graph, 8/7 is just a little bit bigger than 1. So we have -3, -2, -1, 0, 1, 2. Okay, so we can have -3. My graph goes this way. And then 8/7, which is right about there, my graph goes that way. Okay. For part B, we can just subtract 1, 15. So divide out the 5. And we get 3 is less than x. Subtract 9 from both sides. 3x is less than -3. So x is less than -1. And again, a graph would look like this with a circle going that way and a circle going this way. And those would be all of my solution. Okay? So that was section 1-5, solving inequalities.